So if we're going to find the zeros of this one and graph it, we have to start off with our P over Q list again. So our P over Q list, the P is the constant, the Q is the leading coefficient. So we've got 1 and 52, and then 2 and 26, and then 3 doesn't go into it, and then 4 goes into it 13 times. And then we can keep checking our in-between numbers, and then that's all. So then plus or minus all over plus or minus, and then our Q is 1. So then our whole list is plus or minus 1, 2, 4, 13, 26, 52. Right? So if we go look on our calculator, put mine in. So we have an x-intercept here at -2. So I'm going to synthetically divide by -2. I check my powers, 4, 2, 1, none, which means I skipped a cubed. So that means I've got 1, 0, 36, 52. So I bring down the 1. -2 times 1 is -2. 0 plus -2 is -2. -2 times -2 is +4. 36 plus 4 is 40. And then -2 times 40 is -80. Totally done something wrong. 1, 2, oh, I forgot a 1. So 1, 36, then 52. So 2 times 2, -2 times -2 is +4. That gives me 5. That gives me -10. That gives me 26. That gives me -52. That gives me 0. Okay. So notice I had seen that I wouldn't get 0 at the end, which means I knew something was wrong because I knew that the -2 was an x-intercept because I had seen it on the graph. Right? But this only knocks it down to a power of cubed because we started with our x to the 4th power. Well, if I go back and look, there are no other x-intercepts, right? We can scroll in and out, move, pinch and zoom, nothing. But if you remember, it's bouncing at the x-intercept. If it's bouncing, that means it has a multiplicity of 2. So really that x-intercept happens twice. Okay? So that means I can come back here and synthetically divide by another -2. So I bring down the 1. -2 times 1 is -2. -2 plus -2 is -4. -2 times -4 is +8. 5 plus 8 gives us 13. -2 times 13 is -26. That gives us 0, 0, 0. Right? So remember, on your second round of synthetically dividing, you need 2 zeros in order to know that this one is a factor. So now this has knocked it down. It was at a cubed, so it knocks it down 1 more power. So then this is an x squared, x, and then no x. So we've got x squared minus 4x plus 13. We are still trying to find the zeros, so I'm going to set it equal to 0. Okay. Well, I want to multiply to 13 and add to -4. Well, 13 is prime, so it's only 1 and 13. 1 and 13 do not get me to -4, which means that I can't factor it, which means that now I have to use the quadratic formula. So if we use our quadratic formula, I'm going to come up here. We have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So remember, b is the thing with x. That's a horrible looking for. A is the thing with the x squared, and c is by itself. So we have x equals -4 plus or minus the square root of -4 squared minus 4 times a, which is 1, times c, which is 13, all over 2 times a, which is 1. So -4 is +4, plus or minus 4 squared, -4 squared is 16. And then if I do 4 times 1 times 13, that gives us 52. And then I like to do my signs. It's negative times positive, which gives me a -52. So then I'm going to do 16 minus the 52, which gives us -36, which then gives us all over 2 times 1, which is 2. Now remember, when you have a negative underneath the root, that it turns into an I. Right? So we get 4 plus or minus 6i over 2, but I can divide each of those by 2. So 2 plus or minus 3i is our final answer. So we get x is 2 plus or minus 3i, and then don't forget the negative 2's from over here. Right? So when it happened twice, I don't actually need to write it twice. I'm going to erase the second one. But when I go to look at the multiplicity, I need to remember that this is 2, so it's even and bounces. Each one of these appears once. We are not really talking about if it's even or bouncing because it's imaginary, so it doesn't show up on the graph, right? So then we have on our graph, so at -2, we know it bounces. If we go back and we look for our end behavior, it's a fourth power, which means it's even, so it's going to be touchdowning, opening up or down, and then it's positive, so it's going to be opening up. So we're going to have our end behavior is this kind of a shape. And then we have the y-intercept that we can find. We plug in 0, so if we plug in 0 to all of these, we're going to get 52. Right, so 10, 20, 30, 40, 50, and then 52 would be there-ish, right? So we're going to start from the top left. We're going to come bounce. Oh, I made that into a line, bounce, and then come up here. And then that gives us our graph. And we could, if we wanted to, write this in factored form. So we would have f of x equals x plus 2 quantity squared, since we knew the multiplicity was 2, or it showed up twice. And then it would be x plus, not plus, x minus 2 plus root 3, not root 3, 3i, and x minus 2 minus 3i. So then we would need to distribute that negative to both of these. So then we get x plus 2 squared times x minus 2 minus 3i. And then we distribute the negative here, so x minus 2 and then minus times a minus 3i is plus 3i. So then this would be how we would write it in factored form. Right? So that gives us all of our information that we want.